In this lesson, we're going to be solving this question. It is, if x squared plus 1 over x squared is equal to 47, find root x plus 1 over root x. So let's first start by finding the value of x, and then when we get the value of x, we plug in the value of x into this expression. So let's start. We have x squared plus 1 over x squared is equal to 47. Remember, this is over 1 and then this is over 1. Now the LCM of 1 s squared and 1 is equal to s squared. So I'm going to multiply each term of this equation with the LCM, which is s squared. So I'm going to have s squared over 1 multiplied by s squared plus 1 over s squared multiplied by s squared, then equal to 47 multiplied by s squared. So s squared multiplied by s squared is going to be x exponential 4, then plus this s squared and this s squared is going to cancel, so I'm going to left with 1 here, then equal to 47 multiplied by s squared is going to give us 47s squared. Alright, so let's collect like terms. Let's rearrange this equation by taking this 47s squared to the left hand side. When we do that, we're going to have x exponential 4 minus 47 s squared plus 1 equal to 0. So at this point, let's assume y to be equal to s squared. So this equation can be written as s squared raised to the power 2 minus 47 s squared plus 1 equal to 0. So anyway we see s squared, we write y there. So we have y, this s squared, we're going to replace it with y. So we have y squared, which is this square here, then minus 47, this x squared is going to be y, then plus 1 equal to 0. So we are now presented with quadratic equation, and when we solve it using the quadratic formula, which states that y is equal to minus b plus or minus root b squared minus 4ac over 2a. When we solve it using this equation, remember here our a is equal to 1 because a is always the coefficient of y squared. Then our b is equal to negative 47, b is always the coefficient of y, and then c is the constant, which is equal to 1. So when we plug in these values into this general quadratic equation formula, we're going to have the value of our y as 46.97871 or 0.021286. So these are our values of y. Sorry for that. So these are our values of y. But remember, here we made an assumption of equating y to s squared. So anywhere you see y here, we're going to replace it with s squared. Alright, so y is equal to this or this. So anywhere you see y, we will replace it with s squared. So we're going to have that s squared is now equal to 46.9787, or our s squared is equal to 0.021286. So let's go ahead and solve for the values of x. And so we're going to have the values of our x as, so s squared is equal to plus or minus, so we're going to take the square root of both sides. So this is plus or minus root 46.9787, then or s squared, taking the square root of both sides again, equals to plus or minus root 0.021286. So this root here is going to cancel this square, so we're going to have x is equal to plus or minus, if you punch root 46.9787 in your calculator, you're going to get x to be equal to plus or minus 6.8541. So for our second set of the equation, we have x is equal to, if you plug in root 0.021286 into our calculator, you're going to get plus or minus 0.145897. And so we're going to have x values as plus 6.8541 minus 6.8541, then we have plus 0.145897, and then again we're going to have negative 0.1459. Now all of these solutions satisfy this our equation. Now to check this, I want you to check 6.8541 square plus 1 over this square is going to give you 47. The same thing is applicable to the negative sign, and then also 0.145897, and then also check negative 0.145897. And so we're going to get the same answer as 47, or approximately 47. So let's go into the second part of the equation, where we are going to substitute the answer we got into another expression. So we are going to be substituting the values of our x into this equation. So here we have root x plus 1 over root x. So we're asked to find this. So having found our values of x, so for our first x value, we are going to have that this is equal to, we are going to plug in 6.8541 into this expression. So it's going to be root 6.8541, then plus 1 over root 6.8541. I want you to put this in your calculator with me. If you do it, you're going to get, so you have root 6.8541, then plus 1 over root 6.8541. So this is going to be equal to, we have 2.999, repeating to you get something like 679 according to my castle calculator. So this is the value we get when we plug in 6.8541. So let's try for 0.145897. So when we do that, we are going to have root 0.145897 plus 1 over root 0.145897. So if you plug in that in your calculator, you are going to get 0.145897, then plus 1 over root 0.145897. So you are going to get approximately 3.000, so which is the same thing as this. So is 2.999 is approximately equal to 3, and this one is also 3.00. But know that we have square root here, and here we have square root here. So these two solutions is not going to be part of our answers here. So we ask if this is equal to this, find root x plus 1 over root 2. So it's only this and this that satisfies the solution of this our answer that we are looking for. So we're going to throw away this negative 685 and then this negative part of the answer. The reason is because we can't have negative value inside a square root, because we are dealing with a array solution set here. So the answer to this question is approximately 3. Thank you for watching. Please remember to subscribe, like, share with your friends. Have a nice day.